AC to AC controller or regulator converter. That is called as a single phase AC voltage regulator. Okay. So here the single phase AC voltage regulator, by taking two anti-parallel SCRs, that is called thyristors. By connecting the anti-parallel connection of thyristors in between source and load, we can control the voltage. We can regulate the voltage by using these two thyristors. Okay. Two thyristors connected in anti-parallel. The thyristor T1 and T2 are forward biased during positive and negative off cycle respectively. The thyristor T1 is forward biased for positive off cycle, and thyristor T2 is forward biased for negative off cycle. Then the thyristor T1 and T2 are control devices. By using firing angle, we can control the on-off time of the two thyristors. Okay. So by changing the firing angle of two thyristors, we can control the voltage in phase. Phase voltage can be controlled by using the firing angle. So for firing angle 30 degrees, 60 degrees, 90 degrees, 120 degrees, like this, by varying the firing angle of thyristors, we can control the voltage. That's why this is called as a voltage regulator. For 30 degrees, we will get some voltage across the load. For 60 degrees, some other voltage. And for 90 degrees, for 120 degrees, like this, different values of firing angles, we will get voltage across the resistors, different voltage. Okay, so that's why it is called as a voltage regulator. And this is our input supply voltage. This is our input supply voltage here. ES is called input supply voltage. And then, so this is called 0, and this is called pi, 2 pi, 3 pi. And then thyristor T1 is triggered at alpha. For example, firing angle triggered, firing angle is called, triggering angle is called alpha. Okay, so that is called firing angle T1. Thyristor T1 is triggered here. That means thyristor T1 is turned on when we are giving the triggering pulse to the thyristor, and it is turned on. Okay, but diode is if it is forward biased, then it is turned on. But thyristor, even though it is forward biased, it cannot be turned on. By giving the triggering pulse only, it will be turned on. Okay, so thyristor T1 is triggered at positive off cycle, and then coming to the here also 2 pi plus alpha. This is called alpha, for example, alpha and 2 pi plus alpha. Here thyristor will be triggered. Thyristor positive for off cycle. Thyristor T1 is triggered at this position and this position. Only positive off cycle thyristor T1 will be triggered at alpha, 2 pi plus alpha and 4 pi plus alpha, like this. Thyristor T1 is forward biased and is triggered. And next thyristor T2 is triggered for negative off cycle, that is called here in this series pi plus alpha. Okay, and negative off cycle here 3 pi plus alpha. Like this, thyristor T2 is triggered for negative off cycles. Thyristor T2 is forward biased negative off cycle. That's why it can be triggered at pi plus alpha and 3 pi plus alpha, like this. So this is called voltage waveforms across the load. E0. E0 is called voltage across the load, resistive load. And then next current in phase with the voltage. So magnitude is less compared to voltage. This is called current. Where the voltage for this region, year to year, T1 is triggered. That's why you will get current I0. And T2 trigger is year to year. That's why I0 in this direction. So like this current, it changes according to the voltage. And this is are the voltage across the thyristor VT1 and D2. This is called year to year, 0 to alpha, thyristor T1 is reverse bias. So at the reverse bias means the supply voltage present across the thyristor, then that voltage is called this voltage. And then similarly year to year, thyristor T1 is a reverse bias, and then this voltage. Like this voltage across the VT1 and VT2. Okay, and next this can be understand by using MATLAB. Okay, So open Simulink, and go to create model, and new block will be displayed like this. Okay, first take one thyristor, thyristor like this. Thyristor, take thyristors and connect to anti-parallel, like anti-parallel connection. Okay, same as this circuit diagram. It will take some time to display. Like this is called thyristor, detailed thyristor. The thyristor is having anode cathode gate, and this is called to connect the bus selector. To know the RMS value of thyristor current, like this, we have to use this M terminal. So the thyristor is having three terminals: anode, cathode, gate, anode, cathode, gate. Okay, and take one more thyristor, connect anti-parallel by rotating, selecting, and rotate like this fashion. Okay, and like this, two thyristors are connected in anti-parallel. So connect a cathode to cathode, cathode to anode, and anode to cathode in this way. Okay, and next take one AC voltage source. AC voltage source. Place here. AC voltage source. In between there is a load. Na? Take one load, resistive load, series RLC band. Series RLC branch. Open series RLC branch. If you want to know R, change R type, and then take resistance as 10 ohms. Apply OK. Then press Ctrl R, is rotate like this. Okay, and also to turn on this, to give the triggering pulses, try firing pulses to the thyristor T1 and T2. Firing pulse is pulse generator is required. Right here, pulse generator. Pulse generator. Place here pulse generator for thyristor T1, and take another pulse generator for thyristor T2. Press controller, it will be rotate like this. This is called pulse generator 1, pulse generator 2. Okay, and next connect this voltage source to the AC voltage controller like this. Anti-parallel connection through thyristors, and the negative terminal connect in this way. Okay, this is our circuit diagram. And this is a resistor. And to know the waveform voltage across the load, resistive load, to know the voltage across the resistive load, take one voltage measurement, and place here like this fashion. Voltage measurement. This is called just like voltmeter, connect across the connected like voltmeter. This is called voltage measurement. Exactly like voltmeter, we have to connect here. And to know the voltage waveform, take scope. Right here, scope. Take scope and place here. Okay, this is used to display the waveform. And also, if you want to know the RMS value of output voltage waveform, right here RMS, and connect one terminal like this. If you want to know RMS value, and if you want to display this RMS value, what is the RMS value of source current, source voltage, output voltage? Place one display. Take one display. This is useful for to generate voltage waveform. This is useful to generate display what is the value of RMS voltage. And then also if you want to measure the, you want to know the current, okay, connect one current measurement, that is called like ammeter, current measurement, like this. This is called current measurement. Connect current measurement. So here, current measurement. One side of here and another side is connected to like series connection. And this is called current measurement. And if you want to know the current waveform, connect this I to here, scope. Okay. Second one is called current waveform. And the next, this is called current measurement. And also if you want to know the current, RMS value of current, source current, and place here, right, like this. And this is called display, connect display. If you want to know the current waveform, like this, connect. And here, the display, first latter we have to connect these terminals. First, properly you have to connect. Open the scope, and take input terminal. First one is called voltage source, and next triggering pulse T1, triggering pulse T2, and current waveform, voltage waveform. 1, 2, 3, 4, 5. So ports are required. That's why open this, and here, how many ports are required? How many ports? How many ports are required here? 5. Right here, number of input ports is equal to 5. And then okay, apply, okay, close. Then the ports, number of ports are nothing but 5. Okay. First port is called our DC volt, AC voltage source. AC voltage source. That's why I take one voltage measurement, connect parallel to this, and here also connect one AC voltage source measurement, AC voltage measurement, exactly connect to parallel to the source. Like this way, connect this voltage measurement. Oh, okay. AC voltage source. And then this connect to this is input terminals. This is called is input voltage. And then next pulse generator 1. Pulse generator 1. Okay. Pulse generator 1. Then next pulse generator 2. So this is called pulse generator 2. Pulse generator 2. And next this is called current measurement. Current voltage, for example, like connect voltage. And then finally last one is called current. Okay, current wave. Okay, this is called, and then next RMS value of voltage. Connect here voltage to know the output voltage waveform, RMS value of output voltage. Connect like this fashion. And here, what is this input voltage? For example, 230 volts. Peak value, that's why multiply into √2. That is called 1.414. 1.414. Frequency 50 Hz. Then okay. This is our input voltage. And this is called load, 10 ohms. And then next open pulse generator. And here amplitude is called, take amplitude is 1. Okay. Time period is called 50 Hz means what is the time period? 0.02. 1 by 50 is called 1 by 50 is called 20 milliseconds. That's why 0.02 seconds. And pulse width, take pulse width is equal to 30. And phase delay. For example, the thyristor T1 is phase can be controlled at 30 degrees. Right here, 30 degrees. How to convert 30 degrees into seconds means 360 degrees is equal to 0.02. One complete cycle is nothing but 0.02. And then 30 degrees is equal to is nothing but 0.02 into 0.02 into 30 divided by 360. So like this, we have to give time in terms of converted into times in terms of time. Okay, 0.0016667 is called 30 degrees. That can be converted in this way. Then apply and okay. Pulse generator is triggered at 30 degrees, and then next pulse generator is triggered at that 180 plus alpha. That is called pi plus alpha. Same amplitude is 5, and time period is called operating time is called 50 Hz. That's why 1 by 50, that is equal to 0.02. Pulse width, for example, pulse width 30, same as previous one, and phase delay here 180 plus 30 degrees. Okay, 180 plus 30. 180 plus 30, that is called 0.02 into 30. 180 plus 30, 210 divided by 360. Divided by 360. Okay, 0.02 into 210 divided by 360, that is equal to 0.011667. Then apply okay. Like this, single phase AC voltage controller is designed. Okay, and then next time period here, write 0.1. Stop time, write 0.1 and simulate. And here error because of power guide. Take one power guide. Power guide. Power guide. Continuous power guide. Okay. Then simulate. And it's compiling. It's completed. And then RMS value of current is called 23.59. RMS value of current. Load current is called 23.9. Then RMS value of voltage is called 235.9. Output voltage is called 235.9. And then this is called our scope, output voltage, and yeah, separate by using this icon. Okay, press here. This is called layout. Press layout, and here separate like this. 5 waveforms are required or generated, no? So that's why 5 different scopes. Press vertical, and then this will be display. This is our voltage, input voltage waveform. Okay, input voltage waveform, and this is called pulse generator 1. This is our pulse generator 1, and pulse generator 2. This is a pulse for thyristor T1. This is a pulse we have to give for thyristor T1, and this is a pulse for thyristor T2, and this is output voltage like this. Thyristor T1 is triggered at here, and then it will be turned on, and the thyristor T2 is triggered at here. So 30 degrees, 180 plus 30, 210 degrees. So like this, the voltage can be controlled. This is called voltage waveform. And here 200, 400, that means voltage waveform. Here current 0, 20, 30, 40, like this it will be displayed. So this is called current. Okay. So like this, the voltage can be regulated by using firing pulses. Firing pulses. Okay. The output voltage can be regulated by using changing the firing pulses of these two thyristors. For example, here 30 degrees. Na? So for example, 60 degrees. For example, if it is triggered at 60 degrees. So 60, then apply 0.0 into 60 divided by 360. Okay, that is converted into time. And then pulse generator T1 thyristor is triggered at 60 degrees. That means thyristor T2 is triggered at 180 plus 60. So 180 plus 60, that is nothing but 240 degrees. Here instead of 210, right here 240 degrees. 240, then apply. Okay. If thyristor T1 is triggered at 60, then T2 180 plus 60, that is called 240. And then here previous to 235 voltage. Now, what is the voltage? By simulating, we can observe that how the voltage can be controlled. Previous 235 voltage, now their voltage is regulated to 225 volts, and the current is called 22.53. So, like this, voltage and current can be regulated by using this AC voltage controller. And the next, for 60 degrees, what is the output voltages? So, this is our output voltage waveforms. Okay, this is our input voltage and pulse generated G1 and G2, and then this is the output voltage waveforms. It will changes like this. Okay, this called voltage and current waveforms can be regulated by using AC voltage regulator. And then if you want to uh, regulate the voltage at another value of firing angle, okay, 225 now. So you want to regulate you want to decrease the voltage or change the voltage AC to AC. So here 60 degrees to change 60 degrees, for example, 120 degrees or 90 degrees. Take 90 degrees, 90 degrees, then like this phase angle will be changed. Here 90 degrees means here 90 plus 180 plus 90, that is called 270 degrees. 270 degrees. Then apply OK. Then voltage changes to 178.2 and the current is called 17.82. Like this, current and voltage can be regulated. And then what is the corresponding output voltage waveforms? So changes like this. This is the changed voltage waveform. 90 degrees, thyristor T1 is triggered. And this thyristor T2 is triggered at 90 degrees. So by changing the firing angle, by increasing the firing angle of this, what happens is voltage, output voltage is changes. Output voltage can be regulated. Okay. The output voltage can be controlled by changing the firing angle of these two thyristors. This is called single phase AC voltage regulator.